Now we will consider the same thing here. We have two different equations. We can consider g of t minus tau x star of tau d tau and this equation. And for the time being, we already know that x star of t is nothing but sigma k 0 to infinity x of kt into del of t minus kt, x of kt del of t minus kt. Therefore, I can apply this integral 0 to t g of t minus tau x star of tau. Instead of tau t, I can replace with tau, and here I can replace with tau. Therefore, sigma k is 0 to infinity x of kt del of tau minus kt into d tau. So when I have replaced this, I will be getting y of t is equal to sigma k 0 to infinity. Without loss of generality, we can interchange these things, and integral 0 to t g of t minus tau x of kt del t minus kt into d tau. Right. So with this in mind, you can say that sigma k is from 0 to infinity, and this integration is happening between g t minus tau d tau and del t minus kt. So I can replace this x of kt here, and this can be replaced. Now this is a train of unit impulses for every time period t, or you can, because this is coming into this into the summation, you can say kt minus tau, and you can just replace this with g of t minus kt. Right. So a tau can be replaced with t minus kt. Right. G of t minus kt, del of t minus kt, you will get g of t minus kt. Already you have the same function. Therefore, anything multiplied with a unit impulse, you will get the same value. Therefore, you are getting this function. So this is equal to y of t. Now we will use this equation to find out the star Laplace transforms that we are trying to discuss. We will have to prove this equation. Therefore, we are going to see what is happening while using this equation. So using this equation, now what is it that I require? I require the z transform of y of t. Z transform of y of t is nothing but y of z, which is nothing but is equal to sigma. Already I have used k is equal to 0 to infinity, so I will use n is equal to 0 to infinity, and therefore now what is this? Y of kt z power minus n. Right. Since I am using n here, I will use n here and z power minus n. Now I will replace y of nt here, that is sigma k 0 to infinity x of kt g of t minus kt into z power minus n. Now we can say that when we are bringing this into n term, I will use this here as nt. Now we can say n minus k is equal to m. When n is equal to 0, m is equal to 0, and when n is infinity, m is infinity. when m is equal to n is equal to 0, you have m is equal to 0 when, because it is actually m is equal to minus k, and g of nt minus kt is equal to 0 for all n less than k. This is already assumed for us, we have already assumed it, and similarly x of nt minus kt is equal to 0 for all n less than k. So in either case you can use this equation. Therefore, when n is varying from 0 to infinity, m is also varying from 0 to infinity. Therefore, without any loss of generality, you can replace this y of z. I am coming with this y of z is equal to this. Therefore, sigma n is equal to 0 to infinity, I can call it as m is from 0 to infinity, k is from 0 to infinity, x of kt, g of mt, and z power minus n is equal to m plus k. Right. Now what is that equation that we are going to get? Y of z is equal to sigma m is 0 to infinity, g of mt, z power minus n. Sigma m 0 to infinity, g of mt, z power minus n, and sigma k 0 to infinity, x of kt, z power minus k. Now with this in mind, you can say that by definition, you can say this is g of z and this is x of z. This is x of z. Therefore, y of z. Now you consider these two equations. The equations with this, we have proved that y of z is equal to g of z into x of z. Now consider these two equations. This is star Laplace transform of y of s, which is equal to g star of s and x star of s. And how did we obtain this? With this basic equation, basic diagram, g of s and y of s. If this is y of s, this is x of s, this is x star of s. From this equation, from this diagram, we obtain that y of s is equal to g of s into x star of s. And this is the normal Laplace transformation that we have applied here. Now when you are applying star transformations to this equation, y star of s is equal to g of s into x star of s the whole star. That is what we have proved it here. We have already assumed that y star of s is equal to g star of s into x star of s from this equation, from this star Laplace transformations. Right. So from this equation we have derived the z transform of y of z is equal to g of z into x of z. Now you can say that equation 1 and equation 2 both are similar when you are going with this relationship between s and z. What is the relationship between s and z? This is s is equal to 1 by t ln z and z is equal to e power st. So with this you can say that y of z or y star of s, this z transform y star of s is the z transform of y of t, g star of s is the z transform of g of t, and x star of s is the z transform of x of z. So with this in mind, you can say that from this equation you are getting this equation, or this equation indicates that the star transform of y of s is equal to the product of the star transform of g of s and the star transform of x of s. So this is star Laplace transformations.